Hi everyone, let's just have a little look at normal distribution because I think sometimes it is a little ambiguous. So let's just have a quick review of the normal curve. We already know that using the empirical rule, if you look at a normal distribution curve, that there is a mean value. And that mean value is the center of this, like, of symmetry for your normal distribution table. And then as you move to the right, each standard deviation has a unique property to it. So if you move one standard deviation to the right, about 34% of your data is in this piece right here. So if you have the +1 standard deviations to the right and -1 to the left, then you'd have 34 plus 34, which would give you about 68% of your total data. The trick comes in is, what if you don't have complete standard deviations like 1 or 2 or 3, so that you're using the nice values of 68% and 95% and 99.7%. What happens if you have different percentages? And so that's what we're going to kind of have a look at today. One of the problems from our homework said use the standard normal distribution table to determine the percent of data less than 1.7. So that means that we have a mean over here and that we have a z-score. Okay, so I'll look at calculating z-scores in a minute, but a z-score is essentially a number along this horizontal axis, and it's kind of like a distance away from the mean, a z-value away from the mean. And in this case, it's a z is a 1.7, so it's 1.7. It's positive, so it's to the right of the mean. If it's negative, it would go to the left of the mean. So it kind of, what it's telling me here is, okay, at my z-score of 1.7, I want to find all the percentage of data that is less than 1.7. So less than would be in this direction. So the question is essentially asking, okay, so what percentage of statistics fall in this big hump area that's less than 1.7? And in order to do that, we're going to need to use our z-table. Okay, so I pulled up a z-table here, and if I scroll down kind of slowly, you'll see some of the values here. I'm looking at 1.7. So what I do is, on the left-hand side here, here's my z value. Okay, and then these are my decimals. Okay, so it looks like I have 1, I need to go down to 1, and there it is, and I have a 1.7, and essentially, since there's no other values here, it's like a 0, so it's going to be in this column here. So if I go down, I have a 1.7, and I slide over to the 0, 0 column. Let's see if I can, there. And notice that's my decimal here, 0.9554. Okay, so what that is that is a decimal, 0.9554. And that is a percentage as a decimal. So what we're going to do is we're going to turn this into a percentage value by multiplying it by 100. 0.9554 times 100 is equivalent to 95.54%. So here's one way of looking at it. If this is the entire curve from, I'll change my color, from here all the way over here, and I color it all in, and I go all the way out to the left and all the way out to the right, essentially my area is a whole one. It's a whole normal curve. But because I'm stopping my curve at 1.7, and I only want the values over here to the left of 1.7, I only want these guys, I'm actually looking at 95.54%, not the whole curve. So what it does, the z-table gives you a value as a decimal, and that decimal is a kind of relating as a out of 1. I have 0.9554 out of 1, which can be equated to 95.54%. So the percentage of data less than 1.7 is 95.54%. Well, many problems won't actually give you the z-score, and you're going to have to find the z-score. So let's look at another problem from your assignments from week 3. Assume that the hold time of callers to a cable company is normally distributed. Okay, as soon as you see normally distributed, you're going to draw this little normal curve just like this. So the first thing you want to do is you want to draw. And it has a mean of 5 minutes. So in the middle, I'd put the number 5. It has a standard deviation of 0.9 minutes. It's not even a whole minute. So I write off to the right, my standard deviation is 0.9. We want to determine the percent of callers who are on hold between 4.7 minutes and 6.7 minutes. So we want to look at the value here between 4.7 and 6.7. So 4.7 is pretty close to 5, and 6.7 is the value that we have over here. So what we're going to do is we're going to try to compute the area, or that decimal percentage, for values in this shaded yellow area. Okay? All right, so what we're going to need to do is convert our values to z-score so we can use the z-score table. So the first thing I have is z is equal to find the z-score, you take the value, in this case our first value will be 4.7 here, and you take your value, subtract your mean, divide by your standard deviation. So our first one here is going to look like, I'll do it up here, it's going to be my first z-score is equal to 4.7, subtract my mean, which is 5, and I'm going to divide by my standard deviation of 0.9. Okay, so my top value is 4.7 take away 5, leaves me with a negative 0.3 divided by a 0.9. Okay, and then so I just put up here the rest of the work so it didn't take so long for you to watch. But what we're going to see here is we actually end up with a nice decimal of negative 0.33. And then that's a value that's going to be looked at here with the 4.7. Also down here, I've created one with the 6.7. So I do 6.7, which is my value, take away my mean, divided by 0.9, which is 1.7, divided by 0.9, which gives me a z-score of 1.89. And I just have them in 2 different colors so that we'll be able to see them in 2 different colors on the table below. Okay, so to find the negative decimal 33, first of all, you go down to the 0.3, and then you go over to the 0.03, and this value here would correspond or correlate to 0.33. Now, it's a 62%, 63%, or 0.63 approximately. And what that represents, I'm just going to jump up here to this graph here. What that represents is this value here. It's 63% of my data lies to the right of my point of 4.7. Okay, so 63% of data approximately lies in there. And then my other value of 1.89 is at the bottom, and it's kind of cut off here, but I have a 1.8 here, and then I go over to the 0.09, and I have a decimal 976. So it's about 97% of my data, about 97% of my data lies, I'll do it in yellow. It's from here to the left of here. Okay, so the last thing we're going to do after we have the tables, we're going to compute. We know that about 62.93% of my data. So we have about 62.93% is going that way over here, and we know that was 97.06. So we have a 97.06 as going to the left. So basically you want to find the value in between. So what we're going to do is we're going to take that 97.06 and we're going to subtract 62.93. So my final percentage is 34.13. So that would be that would tell me that 34% of calls are on hold between 4.7 minutes and 6.7 minutes. We're going to do one more example and we're doing it just a little bit faster. Here we have a problem where you're looking at SAT scores that are normally distributed. As soon as you see normally distributed, you're going to draw this little picture, this little slopey line. The mean is 500, so he will go in the middle. And it has a standard deviation of 100. The question is now, what is the percentage of students who took the test and they have a mathematical score that's below 590? So I'm going to put 590 over here, and we want to have a look at all of the students who scored less than 590. So we want this ginormous area here. Okay, so the first thing we're going to do is we're going to convert my 590 into a z-score. Okay, so having a look at this problem here, 590 take away 500 is 90. Remember, it's your the value in question, take away your mean divided by your standard deviation. You want to find the z-score for the 590. So 590 take away 500 divided by 100 is 90 divided by 100, which simplifies to 0.9. So there's my decimal. That's my z value that I'm going to look at in the z table down here. I go down to 0.9 and then I have nothing after that. It's a 0, 0. So this corresponds to a decimal of 0.8159. So 0.8159. Now remember, that is a percentage of an entire normal distribution curve of a value 1. So I want to turn that into an actual decimal, which is about 81.59% multiplied by 100, and you'll end up with your percent. So what that is telling me, that's the percentage of students who are going to score less than 590. So that's telling me here that about 81.59% of students are going to score in this area down here. And if you wanted to find the students that would score above, you would just take 100 and you would subtract 81.59, and that would give you the percentage that would score in this upper area over here.